So recently I've been learning about bit shift operations and I wanted to make a quick video going over some of the basics. I'm going to go over a simple problem, which is counting the number of bits which are set to 1 for a specific number. Say you've got a number like 0. We know that the number 0 has 0 bits set to 1. Say you've got a number like 3. We know that the binary representation of 3 is 1, 1. In this case, the answer should be 2. And of course, if you've got a number like 8, the binary representation is 1, 0, 0, 0. So this time the answer should be 1. You can keep going on and on. So if you've got a number like 15, the binary representation of that is 1, 1, 1, 1. So the number of bits set to 1 for 15 is 4. Turns out that if you're learning bit shift operations, this is one of the easiest ways to get your feet wet with it. And of course, we're going to be learning how to do this in C++ because JavaScript is garbage. Collected, of course. Let's just go through the problem that I've set up right here. So I've got a couple of numbers. These are the same numbers that you've seen here and the expected result. What we want to do is go through the numbers array and find the number of bits for each one of these numbers and then print the result. If I go to this count1bits function, all I'm doing right now is returning 0. So here is that result in the terminal. You've got the number 0, binary representation 0, the result that we are calculating is 0, and the expected is 0. So this is the only one that's correct. All the other ones are incorrect because, again, we're just returning 0. So how do we calculate this value? And to do this, we're going to want to actually open up LLDB. First, let's just print a variable like 8. All right, that's an integer of 8. What we want to do is figure out how do we actually calculate the number of ones in 8. First, we're going to print the binary representation of this, which is done by saying p/t and pressing 8. In order for us to not have to look at all these zeros, we can just cast this binary representation into a uint 8_t, and that will remove a bunch of zeros for us. So in order to solve a problem like counting bits, we need to understand two types of bitwise operations. The first operation is the right shift operation. So what does the right shift operation do? So let's say I've got p of t once again, and the right shift operation is the double greater than signs, and then let's right shift by 0. What does that do? That actually does nothing. Okay, so let's right shift by 1. What does this do? It shifts all the values by 1 to the right. Now this is a very fast operation on the computer. What does this actually do for the number itself? We can figure out what this does in the number if we go and instead of printing out the binary representation, just printing out the regular representation with p. Oh, here we're casting, so let's undo this cast. This operation is essentially the same as dividing by 2. So if I were to bit shift twice, then we divide by 2 twice. If I were to bit shift 3 times, we divide by 2 3 times. This is the first operation that we need to be familiar with. We are able to shift things to the right, but how does that help us count the number of ones in the number 8? Well, the other operation that we need is the AND operation. So what is the AND operation? So 1 and 1 returns the value 1. What if we do 2 and 1? What do we expect? First, let's print out 2. What is 2? 2 is the binary representation 1, 0. Now what is 1? Binary representation is 0, 1. So what would happen if we do 2 and 1? What do you expect? The answer should be all zeros, because we're trying to do an AND operation with this 1 and the 0, which is going to return 0, and we're trying to do an AND operation with this 0 and this 1, which is going to return 0. So how do these two operations help us? Well, that's where the key trick is. Let's take the number 13. And let's just print it out real quick. So you've got 1, 1, 0, 1. That's 13 in binary. Now, what if you AND this value with 1? What do you expect to get? If the final bit in 13, or whatever the binary representation of whatever number it is 1, then we'll get a 1. And if it's not, then we'll get a 0. We know it's 1, it should be 1. So there we go, we get 1. And now, let's try something interesting. Let's bit shift 13 to the right. Now we've got 110. So we've essentially figured out that the first bit in 13 is set to 1, and we've bit shifted it right, and that moves all the bits 1 to the right, and now we can do the thing all over again. So we bit shift to the right, and now we take the value with and 1. Now we're going to get 0. Because this value is 0, and if we're adding that with 1, we're going to get 0. So now let's do this one more time. Bit shift 13 2 times. This 13 value here, which is 1101, has been bit shifted twice to the right, so it's going to be 1 1. And now let's run this operation with an and with 1 more time, and this time we'll get 1. Cool. So far we've essentially counted this one and this one. So we got 1 over here and 1 over here. And now the last thing to do is to do bit shift 13 to the right 3 times, and then add that with 1. And so we've got our 3 bits here. So that is the operations that you need to do to count the number of bits. Let's see how that actually looks like in the code. We can start by having an int count variable. Int count equals 0, return count. While true, we want to iterate over the number. This iteration is a little bit different because it's a bit shift type of iteration. So let's see how that works. If the number is equal to 0, then we can just return 0. Or I guess we can break. If the number is 0, then we can just break out of this while loop, and count is equal to 0. So it's going to return 0. So that's correct. Now, what's the other operation that we need to do? If the number at ampersand with 1 is equal to 1, what do we know? So let's take the 13 number once more. What is this add with 1? Well, it's 1. So what we know is that we can increment count because this implies that the last bit is set to 1. And now all we need to do is bit shift the number to the right one more time. So we say num equals num bit shift once. So this loop is going to keep shifting these bits 1 to the right and checking the last bit every single time. So in the first iteration, it'll look like this. And in the second iteration, it'll look like this, which is 0. In the third iteration, it should look like this, which is 1. And in the fourth iteration, it will look like this, which is once again 1. And in the final iteration, we actually won't make it this far because the number is going to break out right here, because number, if it's equal to 0, it's going to break. And there you have it. That's how you count the number of bits with a bit shift and an AND operation. I'm going to do make once more time, and now let's do /main. And now we get the correct answer. And yeah, if you made it this far, I'd appreciate it if you could just hit the like button and consider subscribing for more content just like this. Thanks for watching, and I'll catch you guys next time.